Welcome students to the second lecture for Module 2. In the first lecture you learned about z-scores and how to calculate z-scores. You also learned how to get raw scores from z-scores. So here in the second lecture we're going to take what we learned from the first lecture and we're going to take z-scores and we're going to calculate percentiles. In other words, we can compare individual scores to the overall population, not only in terms of z-scores but also in terms of percentiles. If you remember from the very first lecture, our formula for z-scores was taking an individual score, subtracting the population mean, and then dividing by the standard deviation. So again, we do what's in parentheses first. We'll take the individual value, subtract the mean, get a number, and then divide by the standard deviation. Now once we have a particular z-score, we can then find where that z-score falls on the normal distribution. Now remember, the normal distribution is broken up into regions where each region is associated with a certain percent of the population. So we're going to take this one step further and go from percents to percentiles. Now a percentile tells us the percent of the population that falls below or is less than a particular z-score. So in essence, we're starting from the left of our graph and moving to the right. So we'll start at negative infinity and we'll go across our graph until we find or till we meet that z-score that we're looking to get a percentile to. So we're always working from left to right. We want to know the percent of scores that fall below or less than a particular z-score that we're interested in identifying. So let's go back to our example from the first lecture of Module 2. We were talking about height and converting height to a particular z-score. Now we're going to take height, convert it to a z-score, and then convert it to a percentile. So that for any one person, we can find out their percentile in height, or in other words, the percent of the population that is shorter than that particular person. So let's say we want to know the percentile for someone who is 71 inches tall. The first thing we need to do is to take that score of 71 inches in height and we need to convert it to a z-score. And we've done this before, so we've seen this in the last lecture. But we would take our individual score, x, our individual value, and we subtract it from the mean of the population height, which is 67 inches. So we'll take 71 minus 67, we get 4 inches, and we divide by the standard deviation of 4.13 inches. So that would give us a z-score of 0.97. So we could say that someone who is 71 inches tall also has a z-score of 0.97. So we now want to find the percentile for this z-score of 0.97, in other words, for this person who has a z-score of 0.97 in height. And so we can place this z-score of 0.97 on our normal distribution, and again it falls right before a z-score of 1, so 0.97 is right before a z-score of 1, and we want to know what percent of the population falls below, or in other words, is shorter than this z-score of 0.97. And so essentially what we're looking for is the area of the distribution, of the normal distribution, that is to the left of a z-score of 0.97. We can rephrase that to say that we want to know the area, or the percent of the distribution, that is from negative infinity all the way up to a z-score of 0.97. Now we already know something about this distribution. We know that the distribution is symmetrical. We know that it is split at the mean, or the middle, a z-score of 0. And we know that the left and the right side of this distribution mirror each other. And so we may not be able to calculate the percent from negative infinity to a particular point, but if we start at the middle of the distribution and work our way out, then we can make some assumptions. And so the very first assumption that we can make is that if our distribution is symmetrical and is divided right in half at the mean, then we know that the left half of this distribution should account for 50% of the population. So we know our z-score of 0.97 is greater than the 50th percentile because the z-score of 0.97 is more than halfway past our distribution. So we know it's above the 50th percentile. We know the left half of this distribution is 50% of the population. What we need to find is the percent of the distribution that falls between a z-score of 0 and a z-score of 0.97. So the region we're looking for is from the mean to our z-score. In other words, from the mean of a z-score of 0 to the z-score of 0.97. Now we can already see that 34% of the population falls between a z-score of 0 and 1z. And so we know that the percent that's going to fall between the mean and our z-score is going to be around 34%, or maybe a little bit below that. And so once we find that actual percentage, that specific percentage, we'll then add it to 50%, and that'll help us get our percentile. So we need to know the area of the distribution from the mean, a z-score of 0, to a z-score of 1. Luckily for us, someone has already done this calculation. And so if you have your textbook, open up your textbook to the appendix. So it's Appendix B, and it's Table B1, and it's titled the Z distribution. So in this table, someone has already categorized or calculated each of the percentages of the distribution from the percent from the mean to the z, and also percentages in the tail. And so we can use this table to help us find the percentile. Now remember, we're looking for the percent from the mean to the z, and you'll see that there is a column that's labeled that'll help us get this percentile. Alright, so let's talk about the table for a second. You'll see that there are essentially 3 columns, and those 3 columns are repeated. So there's a column for z-scores, and it's labeled with a z. There is a column from percent mean to the z, and so what we mean by that is from a z-score of 0 to whatever z-score that we're looking for. And then there's a column called the percent in the tail. So this particular column is focused on the z-score, the region of the distribution, or the percent of the population as from the z-score to either infinity or negative infinity. Now if you remember, we're interested in knowing the percent from the mean to the z, from a z-score of 0 to a z-score of 0.97. And so we're not going to look in this third column, we're going to want to look in the second column on our table. So we're going to focus our attention on the very first 2 columns, the column labeled z, that's where we're going to look up our z-score, in the column that says percent mean to z. So in your book, go ahead and turn the page. So the number we're looking for is not on that very first page of the table. There's 3 pages to the table. So we'll move on to the second one, and we'll look for a z-score of 0.97. And so as we go down our z column, we eventually get to 0.97. It's near the bottom. There's an arrow right next to it. Make sure you can find it in your textbook as well. And then we're going to move over to one more column, and that'll tell us the percent from the mean to the z-score. In other words, the percent of the population from a z-score of 0 to the z-score we're looking for. In this case, 0.97. And so we'll see the number 33.4. So that tells us that there is 33.4% of the population that falls in the region of a z-score of 0 to a z-score of 0.97. Now it's important to note that this is not our answer. Remember, we have a positive z-score. This just tells us from the mean to the z, we still have to add the other half of our population distribution. So we will take 50%, so remember that's half of our population distribution from 0z to negative infinity, that's 50% of the population, and we're going to add the percent of the population that falls between a z-score of 0, the mean, to a z-score of 0.97. And on our table, we said that was 33.4%. So we add those together, we get 83.4%, and we'll go ahead and round to the nearest percent. So we always talked about before going to 2 decimal places. Percentiles are the only one where you will not go to 2 decimal places. So percentiles are whole percents, or percents divided up into 100%, and so there's no reason for decimals. So here we'll say that a z-score of 0.97 would fall in the 83rd percentile. Or in other words, someone with a height of 71 inches would fall in the 83rd percentile. We're saying that 83% of the population is shorter than this person with a height of 71 inches. So if we go back to our original question, what is a percentile for someone who is 71 inches tall? Based on the data that we collected, the mean and the standard deviation that we collected from our Stats 2010 class, we calculate a z-score of 0.97. We then go to our table, and in this case it's table B1. and then we look up the percentile. In this case, remember, because it's a positive percentile, we still have half of a distribution to add. We'll take 50% and add it to the portion from our table, from the mean to the z-score, in this case a z-score of 0.97. We add them together, we end up with the 83rd percentile. Let's go ahead and let's do another example. Now let's say the person that we're trying to get a percentile for is shorter than the average in the population. So let's say we have someone who is 61 inches tall, so this is 5 feet 1 inch, and we want to know what percentile is this person when it comes to height. So just like before, we need to take that height of 61 inches, we need to convert it to a z-score. And so if you remember, our population mean was 67 inches, the population standard deviation was 4.13 inches, and so we're going to take our formula for a z-score, and we'll take our height of 61, we'll subtract the mean of 67, that gives us a number of -6, so this person is 6 inches shorter than the average in the population, so we have -6, and we'll divide by the standard deviation of 4.13. Now remember, you need to know what the symbols represent, so make sure you review those for when it comes to an exam. Once we calculate our formula, we find that we have a z-score of -1.45. And so we can take this z-score, we can locate it on our distribution. So visually we can see that it falls to the left of the mean, or in other words, a z-score of 0. And so we can put a line there at -1.45z, so it falls between -1z and -2z. And what we want to know is what percent of the population is shorter than the z-score of -1.45. And so we want to know from -infinity all the way to this point of -1.45, what percent of the population falls within this region, or is shorter than this person who is 61 inches tall. So if we're looking for a percentile and it's a negative z-score, then we can go directly to our table. So remember, in our table on page B1, again this is the z distribution, we have a column for z-scores, and we already calculated our z-score to be -1.45, and we want to know the percent from -infinity to that negative z-score. In other words, we're looking for the region of the distribution that is in the tail. And so our third column is called the percent in the tail. Now you'll note in your table that there are no negative values. And that's fine because our normal distribution is symmetrical. So we can use the positive z-score values to help us with the negative z-score values in finding percentiles. And so we find our z-score of 1.45. Now we have to remember it's a negative number, and so we're going to look in the third column, so the percent in the tail. So we want to know the percent of that distribution that is in the tail, and we see that there is 7.35%. So we can say someone with a height of 61 inches is taller than about 7.35% of the population. So if we go back to our normal distribution, again we're looking for the percent of the population that is in the tail of the distribution. We look in that third column on our table, and we got a percent of 7.35%. We want to convert that into a percentile, and so we'll get rid of the decimals, we'll round, and it looks like that this particular person who is 61 inches tall is in the 7th percentile. So we could say that 7% of the population is shorter than this particular person. So to walk through the process again, we can take our height of 61 inches, we can then convert it to a z-score. We end up with -1.45z. We can then look that up on the table, and again, because it's a negative z-score, we'll look in that third column, percent in the tail, and we will find the particular number that corresponds with -1.45, and then round it to get a percentile. And so in this particular case, someone who is 61 inches tall is taller than about 7% of the population, or in other words, they fall within the 7th percentile.